work at Google on the Go team. I work mostly on the standard library. You know, the whole saying that there's no I in team, but there is in this talk, because this talk is about me, basically. This is about my story of my project I worked on, Camlistore, and kind of like interactions with Go and the standard library and how I got into Go. So those are the kind of like the two projects that I enjoy working on the most, and I'm going to experiment on you guys and see if I could make a talk out of it. How I got into Go, what Camlistore is, very briefly. The demos will probably suck because the network kind of sucks, but I have lots of screenshots at least. And kind of like why I added stuff to the standard library over time. So you will not learn anything here. So pre-Google, I wrote lots of Perl and C. I guess nowadays, maybe I would have been writing Python or Ruby or something in C. And so basically my only options were I could write in some fun, slow language, or I could write in something, you know, faster and tedious. And so I kind of, you know, accepted that that was the extremes, and I chose when I wrote in one versus the other. And, you know, I didn't know any better. There wasn't really a better option. Late 2007, I joined Google. And of course, everything's going to be beautiful and perfect there. I'm not going to have to deal with this Perl-C split. And instead, I get C++, Java, and Python. So I got to choose between, you know, fast and unsafe and tedious, and verbose and safe and tedious, or slow and single-threaded and tedious. And so I wasn't too excited. And I didn't pick one, really, because everything had to be in a different language, and different groups wrote things in different languages. There's also this language, Sawzall, that I had a kind of a love-hate relationship with. It made some things easy, but it was also a really weird language. Also Rob's fault. And so then sometimes I would write things in JavaScript, thinking like that would be my common language. And I did weird things where I embedded the SpiderMonkey JavaScript interpreter in Sawzall, which was in C++, and then I could run JavaScript across the whole web, you know, in MapReduces. And then so I could share code, I would embed the same JavaScript in Rhino in Java programs. And, you know, I was searching for, you know, something better. Late 2008, I went to a tech talk, and the Go crew was presenting Go. The part that sticks out, I actually have the chat logs from 2008 to remind myself of this. Somebody in the audience asked whether the language supports closures. And Rob's, you know, flippant response was like, yeah, everyone wants their pet feature. But whatever, it was still promising because it wasn't one of the other languages that I had to work with. So I kind of idly watched it and followed it, and I only discovered while preparing for this talk that Go actually got closures like right after that talk in February. And that was Russ, I guess, had just recently joined the team, and he went and added them. I think the rumor was something like somebody was on vacation, so their normal consensus they couldn't do, and they pushed in closures anyway. 2009, I joined Android officially after kind of hacking on stuff on the side. And I wrote a lot more Java, and it was actually, you know, more depressing. But it was fun fixing Android stuff and working on Android performance. But it was, you know, this downside was I had to write in Java. Later that year, in November, Go's open source. The Hey Ho, Let's Go blog post. 2010. I was working on Android still, and I was trying to rsync the Android source code to this one NFS server that another team was indexing all the source code and making it like searchable and cross-referenced and stuff. But that team could only deal with it, like we were using Git because the Android project used Git, and they didn't integrate with Git, so they said just throw the source code to this NFS server and we'll index it nightly. So I was like, okay, how hard that could be, I'll just, you know, run rsync. The NFS server has really good bandwidth, but ridiculously high latency per file, so rsync kind of sucked at it. So I figured, hey, I'll just rewrite this thing in Go and start off a Go routine for every file and every directory and just have like, you know, one Go routine per directory and file and all of Android going at once and kind of, you know, fork bomb. I didn't understand how the Go runtime worked or anything at this point. So this is, I'm very excited about it though. And so I wrote on our corp buzz instance, rest in peace. I wrote, you know, I love this language, it makes me all giddy and smiley, and, you know, I'm telling my friends this, and, you know, they're like, I don't know about this thing. Isn't this from the guy who made Sawzall? So this is when I start bugging Russ, and I've been bugging Russ probably for about 4 years now. And I said, you know, my program kind of works sometimes it hangs, sometimes it crashes, and, you know, uses lots of CPU, and it doesn't seem to work under 6prof. Notable thing here is, you know, Go had really good tools even 4 years ago, or it had, you know, things like Profiler, kind of, when it sometimes seems to work. And then I was, complaining about other stuff that, as part of rsync program, you have to modify the mod time of the file and the access time or whatever when you copy it over. So, make that stay. So I was trying to figure out how to do this for a 386 and a 64-bit binary. And Russ was like, oh yeah, someone should do that. It's not done. So that was my first contribution. I sent in the os.changetimes function. And thus marks my beginning of contributing to Go. Let's go back in time. Actually look at what code looked like then. So I have a Go directory here, all checked out. We can run go version to get a version, except for there's no go command yet. So let's make a program. Print, hello, GopherCon. So compiling it then was like running 6G, and then you would get, you'd get some crap, and then you would run foo.6, and you would get some crap, and you have this 6.out, and then we could say, hello, GopherCon. But even though, my program is nice and ugly, there was still GoFump back then. So, and I guess the semicolon purge had just happened recently, but yeah, I hadn't really seen that at the time. Other fun stuff. There's GoDoc. Oh, and it's fun to look at the binaries that came with Go at the time. Like now you're used to just having a Go command. And at the time, they crapped all over your bin directory, well, the 64-bit assembler and the compiler and the coverage tool. It used to have a coverage tool that sometimes worked before the Go tool cover. But then there was all this other random binaries like quiet GCC, which was part of the build process. But here we had GoDoc, and look how cute and small it is. It was like only 2.5 meg at the time. Nowadays it's like 15 meg or so. But so let's look at GoDoc circa 2010. So this was the old website. I love that there's this cool video of Russ explaining Go. Maybe I'll embarrass. Oh, network? Is it gonna work? There's this awesome special effect at 19 seconds or so where I don't know who made these.
But one of the main reasons that I enjoy programming Go is that it's just plain fast. Most of my builds when I'm programming take well under a second. Let me show you.
So, yeah. I love that. Whoops. The tutorial, the top, has a section on rotting cats. Classic. Let's go find the package documents. Okay, so look at the standard library then. There's, archive zip isn't there yet. Adam Langley was already going crazy making it a crypto language, and that's all there. Encoding, some of it looks the same. There's a bunch of weird crap under exp. Let's look at some of these. We have a Tetris implementation for native client in the standard library. It is a Tetris clone built on top of the exp, blah, 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 blah. So yeah, Go 1.3 is going to have native client support, but it was actually there, and then 4 years ago. But they just kept changing native client so often that it was ripped out. What else? There's a really good. Oh yeah, X Space War had a PDP-1 emulator in the standard library. That's important things there. An NNTP package. So there's no Go tool. There's no GitHub thing. So if you're going to write Go code, the only place it went was in the standard library. Sync didn't have sync.once or any of these things, but there was actually a once package. And the once package just had a function do. And you're kind of thinking, how could I do something with a function? Where is the state about whether that thing is done? But it was actually just a global map that was keyed by func, because back then, you can actually compare funcs to each other. It wasn't just non-nil or not. So you couldn't use a closure, and the docs actually tell you don't use a closure because the closure is going to be different every time. You can only point it at a function. So there's things were there but different. The regex package is nothing like it is today. There's some things that are same, like match, I guess, and match string maybe. Yeah. Oh, and my favorite, HTTP. So, So there's like a get function. There's no client. There's no server type. There's listen and serve, but there's no like distinct server type. So there's no configuring your server. You can get things, and it returned, basically looks the same, except for it returns a final URL as well. But then there's like client con and server con, and if you look at the type of a handler, it actually has a concrete con rather than a response writer interface. But it's kind of the same. There's handler func, there's handle, but there's no persistent connections. You couldn't have a client instance where you can configure, you can plug in like different whatever. But it looks roughly how it did. Anyway, so that was Go then, and it was I looked at the standard library and it looked like Python or whatever. It was rich. It had all this stuff and then some. Iterable. This was a failed attempt at maybe something that could be iterated over, but no one ever used it. There's a couple weird packages in here that made it into Go 1, like Scanner, which is now Text Scanner. It turns out we never use it anywhere in the Go standard library. I think we just forgot to delete it when we made Go 1. But anyway, okay, trip back in time. So I'm still writing the bus. I did like 6 years in Mountain View between San Francisco writing this bus that should have taken 45 minutes and nowadays takes like an hour and a half or so. And so I had a lot of time to think, and I wanted to write code on the bus. And I'd been thinking about building the storage system thing, but I had written like a lot of different content management systems and whatever, things that stored data and retrieved data and whatever. LiveJournal was the big blogging one I did. I did my own photo system before Flickr, which some people continued to use. I made something to scan all my documents, so I get it and I scan it and then I tag it and categorize it later. My websites are all data-driven and have state. And I have stuff on other people's services, whether it's like Twitter or Facebook or Buzz or Plus or whatever. And I used to have one computer and one file system, and now I have lots of computers and VMs and file systems and phones, and it's kind of, I never really know where my data is. I'm always afraid of when I back it up, am I overwriting some old version of it and losing something, or am I duplicating things on accident? So I kind of wanted a new storage system to unify all my stuff, and I didn't really want to think about file systems, like POSIX file systems, all this stuff. I have things, whether that's like a photo or whatever, but I don't really want to think what to name it or where to put it. I just want it to exist. So Camlistore, because naming is fun, is a content addressable multi-level index storage. The idea being that it's content addressable, so like Git or whatever, the bottom layer is just a bunch of chunks of stuff. This isn't really new. But it's easy because you can sync every which way, and it'll be eventually consistent. There'll be no conflicts or whatever. And all higher level duplicate or merge and stuff is some low level. But the bottom bits of data are just chunks of anything, and dedupes and all that. So then the upper layers, I want to index all that crap and make it searchable and make a web UI and Fuse and command line tools and whatever apps that have an API and have apps that do custom things on top of it. Okay, so today Camlistore, it's been open source for about 4 years. We say it's a way to store, sync, share, model, and backup content, or your personal storage system for life, and whatever, you're in control. It's kind of like Gmail is like your kind of email for life that you never really delete from, and you just go search when you want to find an email. Think of Camlistore as kind of like Gmail, but for all your data for life. And there's no delete operation. You just keep appending to all your stuff, and you go find something if you want to find it. And it'll give you a POSIX file system if you want or not. Again, suck in from other things. It stores on basically anything you want to store on. You could run it in the cloud. You can run it on App Engine. You could run it on a little Raspberry Pi thing. It encrypts and replicates and shards and whatever. It does everything. And command line tools and blah, blah, blah. And it's not only a POSIX file system. It's also, you could just store things like a GPS location of where you are, or every web page you read, or whatever. You don't have to worry about naming. So nowadays, this is like my private instance of photos I took today. And it imports like Foursquare check-ins too and renders those. And these are all pluggable, so you can make different importer types. And you can write the code on the background that does the importing. You can write custom JavaScript code to render it and stuff. And then you can do various searches, whatever, like I'll show you some screenshots of searches because I really doubt this is going to work. It can slurp in, from other sites. It has cute little expression-y Gmail-style searches with little operators. That gets compiled to this big structured thing behind the scenes, and you can also write in that if you want and save those searches. So if you want to do some search that you can't otherwise do. Everything in it is pure Go, from the HTTP stuff, including the TLS, all the JSON and XML stuff, the WebSockets. We're integrating an SMTP server so you can deliver right into it and have it be your mail server as well. All the JPEG thumbnailing, encoding, and decoding stuff is there. The Fuse stuff, Russ made the initial Fuse code that we're now using, and now a bunch of people in the community are maintaining that. All the database stuff, the database drivers, Mongo, Postgres, that's all pure Go. And yeah, does a bunch of stuff. So yeah, I showed you some of the web UI, but you can see here in this screenshot, panoramic photos or make those bigger. Different contexts. There's a directory, there's a check-in, there's some photos, and I didn't have to name that stuff. You can search by location. So here I'm searching for Moscow, and it's finding all photos and also Foursquare check-ins that happened when I was in Moscow. And it's what else? You could search for cutesy little search operators like is Pano or whatever just to see Pano photos. I mean, that just compiles to a search that says the ratio of the width and height is over some threshold. You can combine them, of course, and say, things that are portrait in Paris, and then see all your Eiffel Tower pictures. Or you could say search. This was a search for minus is:image minus whatever the Foursquare check-in thing is. Now you can see, directories and videos, and you can actually play the little video inline by just hitting the play button on there. There's Fuse client, so you can mount it and you can navigate it. And because you never delete anything, you can look at the world at any state and time, because all mutations are just a log of that you requested to mutate something. So you can always, any query that you can do, you can also query at arbitrary points in the past. So you can, if you thought you deleted something, you just look how it was a second ago or a nanosecond ago. And so in this sense, it's a Dropbox clone or whatever. But we don't force ourselves to just be this POSIX-y thing. And there's an Android client on the market. There's also an iOS thing if you build it yourself with Xcode. What are you going to do? OK, so done with 2014. We're going back, 2010. So I wanted to build this thing, but what language was I going to use? I didn't want to use Perl anymore. I was, enough Perl. And Python wasn't really an improvement, nor was Ruby, nor was JavaScript. They're kind of the same language as Perl, in that they're slow and single-threaded and explode at runtime. So yeah, the syntax differs a little bit, but those were out. I didn't want to use C++ or Java because they're just tedious. You repeat yourself a lot, header files and stutter. And even at Google, with its magical build system over bazillions of machines, it was slow to build there. And I was like, how fast is this going to be to build on my local machine, on my laptop? And I was just kind of frustrated with Android's terrible build system, too. So I wanted something fast. And I remembered Go, and I'd been using it a little bit. So I decided to start trying to write stuff in Go. So June 2010, I started hacking on it. And at this point, I have this Camlistore thing. And one of my first commits was actually an Android app. I guess I was on the Android team, so I thought I should start with an Android app. But then I started on the storage server. Where'd it go? So Camlistore D, here's the very first version. There's a makefile because there's no Go tool yet. And apparently my laptop was not 64-bit, so I'm using 8G. And I can make it. And I could run it. And it's going to say, oh, yeah, I need a password. Apparently, this was my configuration, environment variables. Very secure. Make it foo. And I don't have a place to store it, so I will put it there. Anyway, so now I have a server running. Great. Starting in the background. And I had no client yet, but I had this little Perl script. So I can, I don't know, I'll put the README. And I put it there, and the server responded OK. So great. And now I have some stuff that's now in temp. And there's my content addressable blob. So there was the beginning of my server. This is Camlistore node daemon layer 1, like as if I was going to number all the layers at some point, which I never did. So this code is great. I wasn't using factored imports yet because, I don't know, I just wrote it like other languages. I'm still redundantly writing stuff like pointer to string, even though you don't need it. Or pointer to regex, which I also didn't need there. Putting random semicolons in places you don't even need them just because why not? Oh, you can't see it in this, but it's a mix of tabs and spaces everywhere. I wasn't using gofont. Random parens around things because, I wasn't used to it yet. But, I can do some HTTP things and directly comparing. There's still, references to os.error in here, I think. Yeah, because there was no error type yet, and you had to import the OS package to do errors and all that. But, when it actually gets something here, when you open a file, you had to, it looked like C. You had to say it was, read only and some 0, whatever that was, it doesn't matter for reading, but it kind of looks like Go and the HTTP handler. And there's, io.copy, so I can, as I read from it, this is the serving path. The putting is kind of more fun. Make a directory, and then I copied into the, verified the checksum as it went through, and verified that they didn't lie, and Anyway, so that was early Camlistore. So we wanted multiple implementations of everything to keep us honest, both client and server side. So me and my friend Brett Slacken, we were hacking on this. So we wrote also an App Engine implementation in Python. And on App Engine at the time, the only way to do a file upload was via a multi-part MIME post. And so we decided the protocol for Camlistore had to be a multi-part MIME post, so it would work on App Engine as well. And Go had no multi-part MIME. If you remember back in here, there was a MIME package, but it was this one function, type by extension. So there was no parsing of anything. So I hacked on that and got that in July. It was originally prototyped in the Camlistore repo. Coincidentally, Andrew and I have fixed so many bugs in multi-part MIME over the years. Once he flew in and we decided for fun we would just clean up some multi-part MIME bugs. And we went to breakfast first because he flew in pretty early. And we had a couple of mimosas. And we were fine for a while fixing bugs. And then we spent a whole day just not doing anything productive. And so do not try to write MIME code with mimosas. It was terrible. So anyway, at the time, this, okay, so that was July, it went in. Then later, as part of that, I found myself using what is now IO multi-reader and multi-writer a lot. And this was my first package. I don't know if you can see that. There was no beautiful imports. I was importing dot/util/_obj/util. Because I didn't really know how to build packages, and that seemed to work, and I was just kind of fiddling with things until it compiled. And my commit message is also requires multi-part stuff submitted. Requires the new util package to be built first. So you had to build things in the right order to compile Camlistore. And so I got that in as multi-reader and multi-writer. I was still working on Android stuff, and rather than cross-compiling C, which I didn't really know how to do, the Android build system did it somehow, but it was just pages of flags and options and environment variables and paths that I couldn't really resolve on my own just looking at it. Instead, I would just cross-compile an ARM binary and push it, ADB push it to, and then debug performance problems from Go. But I found certain things didn't work, like little stat syscalls, so I fixed that sort of stuff. Back to Camlistore. So all Camlistore mutations are signed with OpenPGP. And so I mailed Adam, who was, I guess I didn't even realize he was on the Go team until I went back and saw the original blog post. He's just a longtime contributor and crypto guy. So I said, hey Adam, how do I do GPG stuff in Go without shelling out to GPG? And I don't really know what I'm doing. I just kind of looked at some specs and I found some buzzwords, and I was like, what am I doing? So notice this is October 11th. This is in the evening. The next day, October 12th, he's unpack the attached tarball, and here's the OpenPGP package. So that was actually in the standard library for a while, and right before Go 1, we we realized it was silly to have OpenPGP implementation in the standard library. So that's now in the Go crypto subrepo. But yeah, good customer service from the Go team. One day latency. So now we're at 2011. I had lunch with Rob about Camlistore, and he was like, yeah, I don't really understand what you're talking about, but he was like, you seem to be having fun with Go. So I was still running GPG as a child process, and the exec package at the time, this is kind of awesome. This is how you ran a program. You would say exec.run, and you would say argv, argv0 and argv in the environment and the directory, and then 3 integers, which meant one of pass through, pipe, or merge with standard out. And yeah, it worked, but your code ended up being, when I redid the exec package, all these minuses went away, and it just became like this one line here, exec command GPG export armor output. So execing commands is a lot easier now. I think June 12th, I filed my first bug, which is about HTTP. That was kind of like the beginning of my accidentally owning the HTTP client and server. That's the majority of what I worked on in the standard library. So I did the client and client transport. Camlistore.org was running a getweb.cgi process to show the recent commits. So I needed CGI support because I didn't want to run Apache. So I added the HTTP CGI thing. And HTTP test was in the same commit. I was probably using it to test CGI. In April, I joined the Go team. Camlistore needed to be able to look up users for when let me show a more modern Camlistore. So you can just put blobs like that, and you can camtool and list all the blobs in the world. You don't really run camtool list ever except for during demos like this. But I could put a file. Do I have any files here? I'll put go readme, and I get a thing, and then I can cam get this thing, copy, and it's JSON. So Camlistore has no metadata. All data is just, all metadata is just data, and it typically is JSON. So filling in these things here, like Unix group and mod time and all this stuff, which the Camlistore schema for representing POSIX files requires, I needed to be able to look up the user, and you couldn't do it in Go, so I added the OSUser package. The reverse proxy, I forgot. Oh, that was for running my website. I wanted Camlistore to be part of my website, but not all of my website, so I wanted my main website to be able to reverse proxy through to the other one without running Apache. JSON, I needed something in syntax error to figure out where exactly the syntax error is. In Camlistore, let's see. Config, Camlistore. So there's a JSON config file, and if I mess it up by say, I don't know, what do I always do? In JavaScript, I always add a comma at the end when you can't have one. And if I run the server now, oh, does it really like that? Maybe I didn't save. Do we accept that? No clue. Oh, no, that's because my little D alias hides standard error. Anyway, so Camlistore has a cute little error message telling you the line and calling offset, a little caret telling you where your error is. Because I kept doing this trailing comma at the end thing, and hunting down, Go would say, problem. And I was like, where is my problem? So this was for Camlistore as well. So you saw Camlistore has all the thumbnails of stuff. So I got obsessed for a while trying to make ping and JPEG encoding and decoding faster. I also wanted to be able to serve all these blobs directly without Nginx and stuff. So I did the send file and in HTTP and stuff. This was a fun fight with the Go team because it was not theoretically pure, and Plan 9 didn't have send file or something like that. So I like to give Rob crap. Anyway, more stuff for Camlistore. Andrew added this, and I was very enthusiastic about it because we needed it for downloading lots of crap. We had some really terrible SQL code at the time. Before this, every database driver kind of had its own API. They were inconsistent, and there was no connection pooling. So we tried to have database support in Camlistore, and it was just a mess. And so I wanted to make a clean SQL layer. Those Camlistore uses to verify things that you pass in are valid. There's stupid little convenience things, but I kept finding myself doing it a lot. Serve content I needed for Camlistore. Right before Go1 came out, I didn't want GitHub URLs in my Go Get thing, because why advertise GitHub? Maybe I'll use something else later. And why use code.google.com? Maybe, I don't know. I just didn't really need a company's name in the URL. I already had a domain name, so added the vanity URL support. I needed that, I don't know, stupid little accessors. I was just crawling through the commit logs trying to figure out what things I actually needed for Camlistore and kind of try to figure out why I did things. This was for Speedy support, back when everyone thought Speedy would actually use NPN, and apparently now HTTP 2.0 won't. So this will be cruft in the standard library eventually. But I cared about JSON encoding speed and decoding speed, kind of for Camlistore, but mostly because I just wanted to win at those tech Empower benchmarks. And so I think we're still at the top. Go 1.3 should be better. So now we're pretty current. Sync.pool I fought for a long time, and I think people finally caved. I had this bug open, assigned to me for a year or two. Do you file it? OK. People would say, I hit this, and I had no way to reproduce it. And then I was using the S3 API and making tons of Amazon S3 requests. And most of them were failing. It was just amazing how many were failing. And so I spent a day just debugging the crap out of this. And it turned out that Amazon's ELB, the load balancer thing, when they respond with an HTTP request, they say, HTTP 1.1, keep alive, this is going to be good. And in the same packet that they send the response and say, things are good, they also send the TLS, I'm closing you down now packet. And the io.reader interface in Go lets you say at the end, you can return n and EOF, or you could just say n and nothing and return 0 EF later. And anyway, interaction with the HTTP server and the TLS stuff, it just meant that we would try to reuse that connection, and then we had a pending request ready to send off, and we would get done with the request, send off the request, and at the same time we were shutting down and reading that alert shutdown packet from Amazon. So Amazon's load balancer kind of sucks in this regard, I guess. They're kind of doing it wrong. The spec says you're allowed to say keep alive and then turn it off, but generally it's not in the same packet. Normally it's after 5 seconds or something. So now we're kind of current. I don't necessarily have much in Go 1.3 that is Camlistore specific, but things I'm excited about. Sync pool. The copying stack stuff that Keith did is kind of cool because it means we won't have random performance fluctuations from one build to the next if you just rearrange some code, which we always had problems with our image encoders and decoders and JSON stuff that you got unlucky where your stack boundaries were and your performance was kind of just good or crap or you never really knew. The precise GC in Go 1.3 I'm excited about mostly because the Android uploader that runs on my phone for Camlistore is ARM, and it's 32-bit, and that's where precise GC really matters, so that'll help performance or memory performance. The other exciting thing in Go 1.3 is if you have a map keyed by a string and you have a byte slice off the network, and you do a string to byte, normally anytime you have a byte slice to a string or a string to a byte slice, that involves a new allocation and a copy. But Russ finally gave me my toy, and this is now free. So it doesn't actually allocate anything. And that matters for me because on Camlistore, when it starts up, it reads the whole index off disk and makes a bunch of data structures in memory. And that takes 10 seconds right now. And I've profiled the crap out of it, and I just can't avoid certain allocations. And now, when Go 1.3 is out, I will just switch to requiring Go 1.3 as a minimum, and then I can not make all this garbage on startup. Because right now, yeah, it's 10 seconds to start up, which is slow. I don't know. We run a build bot for Camlistore, and it occasionally finds differences. It's kind of useful. There's beer in 1 minute, so we can do questions briefly. I don't think, maybe this will work. I don't know. Come on. We'll see what the Wi-Fi does. So what I wanted to do was take a picture. Dun, dun. Whatever. This isn't going to work. Here's the demo I normally give, and it's awesome, so you can applaud after I describe it. So all the queries on Camlistore's web UI are WebSockets, and they're live updating. So if any of the data model in the backend changes, the server pushes the new results or the diff of the new results. And so you can actually go modify things on the server. You can upload something, and the result updates live in the browser. So you can go tag things or change something. So normally I'll take a picture of the audience, and it'll just show up live on the screen. And then I'll do like a search for like a tag live demo, and then on the command line tool, I'll go like add the live demo tag to it, and then it shows up immediately live in that search to show that all search queries are live standing queries and stuff. But yeah, this doesn't work at all. But yeah.